Unexpectedly, the Rock Auto parts are supposedly out for delivery and should show up any time. So I put everything back together. I was expecting to return the truck to my pal, but I'll just take the under tray off, get the belt off, take the compressor off. System's empty, so there's no recovery required because of the massive leak I showed you in part 2. Respect to removing the belt. There's the tensioner up there. We have a 17 mil offset long reach spanner. It's ideal. Don't know if I can do this one-handed or not, guys, for the camera here. Pull it towards the front of the vehicle and slip the belt off. Hang on. And slip the belt off the compressor there. Leave the belt in situ if you're not changing it. It makes it easier with respect to figuring out the belt routing. Take some photographs before you take it off if you don't have access to the manual. I know it's difficult to see you guys. I'm zoomed out as much as possible, but this is actually, I think, the root cause of all the grief here. Again, this line is supposedly leaking. It's contacting the mount, the plastic mount here for the radiator condenser coil. You can see how this is touching here. There's some smashed up plastic here. Pretty sure this car has been smacked up in the front at some point in time, actually, because yeah, this is not right. And then see how close these lines all are. That's all trouble waiting to happen, of course, in the future if you don't make some effort to make sure there's some clearance. So there's 2 plastic clips here, guys, that you can just, push in with your fingers, get them off. Of course, this is the harness for the control solenoid itself. Little tab, just push it down. An awkward position here. Push the tab down. You should be able to slide it down. There you go. Lock's undone. Should come off. You can push the tab there and it will release. Okay, so there's 3 bolts. One behind the line here, one here, one up in this area here. I know you can't see it, but you can see where my finger is. 3 mount bolts. I think the manual says to remove the mount bolts and then undo the lines, but I might do it the other way around. Of course, the system has to be completely depressurized, recovered, and depressurized, guys. Again, this system has a massive leak. I've checked. There's no residual pressure. You don't do that before you take these lines off. You'd seriously hurt yourself. I mean, seriously hurt yourself. My eyesight's a damn sight more valuable than this vehicle. Well, get lanes out the way here. Again, I don't want to keep repeating myself here, guys, but make damn sure the pressure is out of the system. Yeah, that's never been off. Aluminum oxide powdery residue near the O-ring there. Too lazy for this. Yeah, take your time on these bolts, guys, you'll be sorry. Lower position. The long one is the the central bolt at the rear of the compressor. Oh, it's on dowels. That's why it doesn't want to move. Kind of makes sense. Okay, a dowel there and a dowel here, guys. No dowel in this position.
See, and you thought I didn't own a tripod. So obviously when your parts have arrived here, guys, the comparison, as far as I can tell, is all good. This compressor ships with 150 cc's of PAG 46, the correct specification of oil. So I'm going to drain it, and we're going to split the difference on the system here. Okay guys, so I got just a bit less than 125 cc's. Again, the system capacity is 120 plus or minus 10. So let's call it 130, be on the high side. There is X amount of oil in the system. I know I put 30 cc's in there, so that is definitely still in there. And I think we can assume that there's X amount of oil still sitting in the evaporator, right? So what I'm going to do is I'm going to take this down to 80 cc's, and I'm going to put a measure of tracer dye in the system, and I'm going to return that to the compressor crankcase, and that will be my best estimate. And it is nothing more than an estimate. The system could be absolutely grossly overcharged with oil, but I don't think so. That was completely empty. This has had a major leak. It's gushed its refrigerant and its oil, and again, there will be some sitting in the condenser residual in the system. I put 30 in there, so I'm going to take this down to 80. So there's 30 in there. That'll take it to the low side of the capacity plus the residual that's in there. So hopefully it's within reasonable. I hope that makes some sense, guys. I think it's safer to be on the high side than the low side. So that's just a measure of tracer dye. Put the protective covers back in place, guys, when you're ready to mount it. Just be careful. You could easily perceive the pressure relief on the bottom of the casing there as the drain plug. So you might be careful with that, right? Leave that alone. The compressor overpressure relief valve here on the bottom actually comes with a little witness foil. So if the overpressure relief actually blows, it'll break this foil and you'll know, right? But this actually just fell off because the adhesive is gone. Mashed it up a wee bit. That's what that's for. It's fine. Okay, torque specs and torque wrench. You guys see what I'm trying to accomplish here? Take this O-ring off. This has never been off. So I'm going to clean this with a soft brush. Obviously you don't want to scar up the fitting here. Try to what you can, and then the lines, ideally they'd be plugged. With a appropriate pick, whatever works for you. Just try to remove the O-ring here without damaging the line. Kinda self-explanatory, I think, huh? But I'm not trying to over-explain things, guys. I'm just a weekender myself. This is new to a lot of guys watching this, right? Right, so we'll go into the O-ring kit and see if we can replace that. And we might as well replace this one as well, even though it's only been on there a couple of days. Better safe than sorry, right? It has been through a removal and installation cycle, so. There you go. Take those to the bench and see if we can find replacements. So just match up your O-rings there, guys. These are the old ones on the right. And once you've matched them up, lube up the new ones with a refrigerant oil, and install them on the lines. So I'm going to use these bolts, guys, the original bolts. I've cleaned them up on the wire wheel here. Because if you recall, this is one of the problems we had in the first place, because the suction line where it attaches to the compressor's aftermarket, the flange is not quite as wide as the original, so these bolts may very well prove to be too long. So I'm going to use these original bolts. They're the same diameter and pitch. I've checked them. In case you were wondering, guys, these pins, there's a roll pin here, there's a hole, there's a recess in the flange of the line that attaches to here. So this is basically a guidance pin, so you can line everything up. This one's missing. That's the suction line that was replaced. I suspect the guy pulled it out, but anyway, they're there to help you line the lines up, guys. So here's both the suction line and the discharge line on the compressor, guys. Both the bolts are in. They haven't been torqued yet, but I'll show you the torque spec and we'll torque them up. Yeah, barely on the bolt. Barely on the bolt here. This one. Good. Well, disappointingly, you won't find the harness mount tab here, guys, on the aftermarket compressor. But if you, on the upper clamp here, if you draw the harness on this side, the amount of slack that goes to the solenoid is reasonable, so you'll be all right. So, as I said, guys, there's no clamp here for the harness. Up top there, you can just see it there. Draw the harness back a wee bit, and then you'll have reasonable slack here. And then, of course, just attach the connector. Just attach the connector on this side. Good to go. Yeah, that slack is fine. I'll remove the other mounting point here because it's obviously useless. The new belt is on, guys. As I said, take some photographs of the belt running
The only thing that's a wee bit tricky is you have to slide the belt, flat the belt against the timing case cover, or timing belt cover, whatever it is, and slip it behind the tensioner here. That's a wee bit tricky to get that in place, but apart from that, it's okay. As I said, try and keep track of the belt running. I'm going to slacken the belt again later in the process, guys, once it's leak checked and serviced with refrigerant, so I can spin the pulley on the compressor multiple times before I actually start the car. Okay, so I'm just doing an initial leak check here, guys. I've got both the high and low side pressurized to 108 pounds, as you can see there. I'm just going to let things stabilize. I just closed the valves. I'm going to give it, you know, 10 or 15 minutes to stabilize. Then I'll carry out an initial leak check for maybe 10 or 15 minutes. And if it's all good, I'm going to change the desiccant bag again. But one step at a time here. As I said, I'll wait 10 or 15 minutes for it to stabilize, then another 10 or 15 minutes to actually to carry out the leak check, initial leak check. Then I'll change the bag, then a subsequent leak check, then I'll do a vacuum decay check on it, and then if it's all tight, then I'll pull the vacuum proper on the system. I don't know what it's been, maybe 10 minutes, guys. Ish, 108 even. That seems like a good number to start the leak check at. So this is the current pressure, start pressure and the current pressure are the same at the moment, and this is the elapsed time, and the delta P is the difference between the two. So ideally we don't get any difference and would indicate a tight system. Now I might get a tiny fluctuation here, guys, because of the temperature variation, but it shouldn't be much, not more than a couple of tenths. Okay, so at the initial leak check here, guys, at the 15-minute mark, I've lost 1/10 of a PSI. I'm happy with that. It's getting cooler in my garage here, so yeah, I'm happy with that for an initial leak check. I'm going to change the desiccant bag. Get a little strainer cap down, guys. Pull down the desiccant bag and just change it. This one still looks pristine because the system's never ran. Change the O-rings on your cap there, guys, if you have them. Honestly, I don't have them. These are in good condition. I'm reusing them. So lube them up. Keep your new desiccant bag sealed until the very last moment. This is really difficult to get my hand in there and film at the same time. So just nip it up. 10 millimeter Allen socket. 10 millimeter hex socket. As I said, it's only plastic, guys. Don't lean on it, just cinch it up, nip it up tight. That's it. Here's the leak check subsequently after the desiccant change, guys. Again, same thing, right? Start value, current value, delta P, difference between the two, and the elapsed time. So we'll give it 15 minutes and see what happens. Okay, well, I'm happy with this, guys. 17 minutes into the leak check, and nothing hasn't moved at all, so ideal, right? I'm confident to move on with a vacuum process now. Okay, just pulling from both sides here, guys, the high and low side, try and maximize the flow. I've got my micron gauge on here. It's atmospheric at the moment because there's no vacuum in the system yet, and yeah, let's turn it on. This could take a few hours to get this down here. Ideally I'd like to get below 500 microns, but we'll see. I have the ballast valve open for initially here. Probably take a few minutes to start. Oh, there we go, it's drawing down.
close the valve. Very awkward to access this valve. Not great design. Perhaps it's done intentionally so you don't over torque it. In which case it's probably a great design. Yeah, this might take a while. So we'll get back to this. And again, a target here is ideally 500, under 500 microns would be nice. I'm happy with this. This is looking pretty promising. It's only been under vacuum for not even half an hour actually, and it's already under 700 microns, so that's nice. I like this part of the job. I can shag off for a wee bit. So you'll notice, guys, watch the number here, it'll step down, then it'll hit a threshold number, and it'll jump back up. Okay, so about 546 there. Watch, it'll get close to 546, maybe just below it, and it'll jump back up again. And it jumps back up again. So what's happening there is the vacuum goes progressively deeper and deeper and deeper. It's kind of stepping down the vacuum, and as the vacuum gets deeper, it hits the moisture in the system. The moisture actually goes below its boiling point. Yeah, even at these temperatures of 17 degrees in my garage, and it actually vaporizes, and of course that's the whole point of pulling a vacuum in the system in order to extract the moisture.
So check this out. There's a drain line from the evaporator back on the firewall. Like, it's full of cobwebs. How long do you suppose it's been since that's drained anything? It's been a long time, right? So I asked my pal, how long has it been since this air conditioning hasn't worked? I just assumed it had just gone inoperative. Wrong. 2 years this has been inoperative for.
So I'm really happy with that, guys. I've got the alarm set for 500 microns. Once it dips below 500, the alarm sounds. So basically I just let the vacuum continue until I get a consistent alarm from it, meaning it's consistently below 500. Yeah, I'm really happy with that. Just checking the scales here. 0 scales, 50 grams. Close enough for me. So I've got everything set up here, guys. These lines are, the red and blue lines are under vacuum, and the yellow line here coming from the refrigerant cylinder is full of liquid refrigerant. I'm going to fill the liquid refrigerant into the high side here, and we'll see how much we can get in. Our target is 550 grams. So let's go. So you can hear the car running here, guys. Let's put gas in the low side here. Pressures are getting somewhat normalized, the little fraction of the refrigerant in there. This is like watching paint dry here, guys. I'll bring you back in a bit. 550 plus or minus 25. I'm going to go a 575 just to accommodate for the line loss. So there we go. 550 plus or minus 25. So sue me, I'm over by a gram. So I went to the high side there, guys, just to accommodate for a wee bit of line loss that you'll actually get, just to offset that. Hopefully it's right around 550-ish, right? So let's take a look at the pressures. I can hear the condenser fan cut in there. Watch the high side pressure, it should drop now, which it is. And the low side will come up. That was definitely the compressor actually changing its displacement. And everything, of course, works in unison, right? Okay, I think this is some legs test of whether you've got it cold enough or not. Can the glass go below the dew point? Dew point is 16 degrees C in Orangeville here at the moment. And yeah, it's plenty of condensation. Awesome. Sensible checks. Discharge lane. Hot. Can just keep my fingers on it and no more for a second or two. Liquid line. Warm, but not ridiculous. And the suction line. Cool. Yeah. That's the beauty of the variable displacement compressors, is they can maintain a very sensible temperature, you know. It's not gonna burn you cold before it cuts out, you know. It just modulates things and keeps a really steady target temperature. That temperature hasn't really shifted the entire time. Wow, nice. I'm on AC max, of course. Let's just make sure that everything's modulating. Oh yeah, all good. Okay, as I said, I think we'll call it that, boys. That's it. Cheers. I hope Tom Disney made me stealing his signature window sign off.